Hello once again, pre-calculus. Hope you're all having an absolutely amazing day. Fantastic. It's cold outside, but that's okay because we have the love that is pre-calculus within our hearts to keep us warm. And really, what else do you need? I think that pretty much solves it. We should go and find all the cold and the hungry and give them pre-cal because that will solve. Never mind. All right. Piecewise functions. Okay, so a piecewise function says a function may follow different formulas on different parts of its domain. These functions are called piecewise functions because it's kind of like we're taking pieces of different graphs. So graph each of the following functions on its domain. So we'll start off pretty easy here. We've got x squared, 3, and 6 minus x. Now let me go through and talk about what each one of these looks like individually. X squared is a parabola going through 0, 0, right, going up like this. 3 is just a horizontal line at 3. And then 6 minus x is, well, it's the same thing as negative x plus 6. It's a line with a slope of 1 starting at 6. Now, for x squared, it goes from positive 1 and everywhere to the left of that. So everything up until 1 is x squared. Now here's what that's going to look like. Usually we start at 0, 0. All right, let me go in here, go in for the kill. From 0, 0 we go up 1 over 1, up 3 over 1, and I'm just going to put a really light point right here, a little circle here. And then up 5 over 1, for 5 over 1, right? That's what it usually looks like. And then over here, up 1 over 1, up 3 over 1, up 5 over 1. Now if you'll notice, I put solid dots over here. That's because this function, let me erase this one, does not exist to the right of 1. It also doesn't exist at 1 either. So what this thing looks like then, if I can zoom in on this, is going to be this. Let's focus. Yes. It would have gone up like this, right? But it doesn't exist anywhere else except for when x is less than 1. So when x is less than 1, I'm going to have my parabola. So it looks like this. Let me straighten that up. And it keeps going forever. Then when x is equal to 1, your y value is 3. So notice that's only one coordinate. That's a point. Pull back a little bit. When x is 1, y is 3. Okay, so that's just 1 point. Remember, y equals 3 is this entire line right here at 3. But our x values are being restricted to only one value for x, so it's just a point. And then negative x plus 6. So negative x plus 6 starts here at 6. Put an empty circle there. And my negative x, so it goes down 1 like this, and it continues down like this, right? Now notice I'm not filling anything in just yet, because this function only exists when x is greater than 1. So everything to the left of 1 doesn't exist. And notice it does not touch 1. So what it's going to look like then, it will exist everywhere to the right of 1. So it's going to look like this. It'll be an empty circle on 1. Let me zoom in so you can kind of see the difference here. It's an empty circle on 1. And then everywhere to the right, it actually exists. And that's called a piecewise function. All right. Now, these are a little bit different as far as when you're looking at domain and range, what the domain of each will look like. The domain, remember, is your x values. So we're going to look at what x value does this thing touch. Well, it goes from negative infinity, and I'm just going to follow my line, from negative infinity, right? Your x still exists here, still exists, but we've got a jump right here. and then it exists everywhere after 1. So at 1, there's a problem. So the question you're going to ask yourself, I'm going to write this up top, does f of x actually touch 1? And I'm talking about my x value. Does it actually touch x equals 1? And in this case, it does right here. Okay, so let me explain this to you. If this point was not here, let's say that point was not there, then this function's domain would go from negative infinity to 1. It would not touch 1, and it would pick back up at 1 to infinity. But since we actually touch 1, I'm going to go ahead and include it and say it's negative infinity to infinity, or all real numbers. What this tells me is that every single x value is accounted for. All right, what about range? What's the lowest y value you'll go to? Well, a lot of people want to look at this parabola and say, oh, it's 0, but what about this line? See, this line keeps going down forever. So all my negative y values are accounted for in this line. All my positive y values are accounted for in this parabola. Even though I have a jump right here, I'm going to ask myself again, see how this jumps from a y value of 1 to a y value of 5? 1, 3, and 5. Does it ever touch 1? It does right here and also here. Does it ever touch 2? Yep, here and here. 3, yep, here and here. 4, yep, here and here. 5, yes, it touches right here. So it always touches all of your y's. Again, I'm at all real numbers. Negative infinity to infinity. Okay? So that's just a little background. Again, you're looking at, is there any x that I do not touch? That'll tell you your domain. Is there any y I do not touch? That'll tell you your range. All right, let's go down here and graph this. The first part looks like a line. Second part is a square root. Third part is a square root. The first thing I'm going to do is rewrite this as the square root of negative x minus 2. Let me write that up here so I can kind of show you a little bit more, show you where I'm getting at. This guy right here is the square root of negative x plus 2. And I want to take out the negative. So it's the square root of negative parentheses x minus 2. Okay, now a lot of people like to draw these and then erase what they don't need. So if that's you, I'm going to show you how to do this. And I'm going to draw these very lightly. Notice I'm doing this in pencil because we don't do math in pen. Robert, Charles, looking at you. You don't do math in pen. So if we have a pencil like we are supposed to, we can actually graph these normally and then just erase what we don't need. So negative 2x minus 1 starts at negative 1 very lightly and has a slope of negative 2. So down 2 over 1.
Students, you should now be out of the building.
Down 2 over 1.
Waiting, you may wait inside that cubby near
Down
the
2
front
over 1.
office, but you must be out of the building.
Down 2 over 1. We can
Teachers,
also go,
please go
good
home
grief.
and be safe on the road. Watch for the news.
I guess I'm not supposed to be here.
Have a good evening.
Up 2 over 1. Let's finish this up quickly. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, so that's my graph, right? I've graphed all my points. But it only exists when x is less than or equal to negative 2. Well, here's negative 2, so here's my function. Since it says equal to, I'm going to make that a solid point. You can kind of tell I did that a little bit darker than any of the rest of them. And when x is less than, so this line right here actually exists. The rest of it does not. The magic of pencil! It erases! What about the square root of negative x minus 2? So this is right 2 and it's going up and left. So it's going to be opening like this. So right 2, I'm going to put a little dot, very gently putting a dot. opening left, so up 1 over 1, up 1 over 3. And I'm not going to need anything else because after that I'm over here, so I'm done with that. And that goes from -2, not touching -2. So I'm going to make this a circle. I do not touch -2. Touching +2. Yay, it's a dot. Bam. Okay. And then x minus 2, so it starts from 2 and goes up from there. And this is everywhere where x is greater than 2. Notice how we're actually starting on the same point, so I'm just going to leave it a dot. Some people, and if you would like to do this, you are more than welcome. Since we're starting this next one on the same point, you can put a circle around the dot, and that just tells you there's another function starting there. But it still exists. It's not a hole, right? And then up 1 over 1, up 1 over 3, up 1 over 5. And this is your first introduction to piecewise functions. Now for x's, is there ever an x that is not defined? I'm going to look right here at this hole, -2. But just above it, see that hole right there? Or that solid point? That will fill in that hole for my -2. So I'm okay there. I've got a point to fill in -2. So my domain is all real numbers. Now my range, however, the lowest y value I'll go to is 0. So it is going to go from 0, touching 0. Now, I go up and there's a hole, there's a skip right here between 2 and 3. So after I find that hole, I have to look everywhere else on the graph and say, does anything fill in that hole? Do I ever have anything between 2 and 3 on the y value? Yeah, I do right here. So that's taken care of. So then it just goes up forever. Infinity. And I'm guessing I should not be here right now for some reason, so I'm going to go home. That's really all there is to it. Piecewise functions are just like any other function we've done. The only new thing is we're now taking pieces of them off. All right? Y'all have a good one.